the focus, as I see it in the industry, is shifted from sometimes making the models into make them work well in the real world and be able to be flexible enough and adapt changes. So that's, I guess I can say that many times maintaining the model and make it good and reliable out there is sometimes much harder than actually developing it.
You're listening to Gradient Descent, a show about machine learning in the real world, and I'm your host, Lucas Biewald. Nimrod is a senior computer vision algorithms developer at Nanit and the father of 2 children. Nanit develops smart baby monitoring systems, and it's a product that I happen to use every day, so I'm extra excited to talk to him. So Nimrod, I'm super excited to talk to you about the article you wrote on ML in production, but I'd say I'm especially excited to talk to you because you make maybe the app that I use the most these days, the Nanit app. So my daughter actually turned 1 today, and we've been using it for the last year. And basically every morning, my mother-in-law and my wife kind of discuss the stats from the previous night's sleep. So I really, really love your app. I can say that honestly. And I was proud to discover that you were customers of Weights and Biases. But I was wondering if you could start by maybe talking about what your app does and what the history of the company is and how you think about that.
Yeah, sure. So first, happy to be here. And the whole company started by an idea of one of Asaf, one of the founders, that actually wanted to monitor his son's sleep, during the night, since he came from the whole world of processes and monitoring using cameras, and he wanted to take that to his son. And it started as a project when he was at Cornell University, and everything just rolled from there, actually. And since we have a camera and he is from the field of computer vision, the company started doing a smart baby monitor using computer vision algorithms that can track, as you know, sleep, also the breathing motion, and let you celebrate them. Milestones of your baby, for example, falling asleep first time on his own, and sleeping through the night without any visits from the parents, which is great for us, the parents, of course. And they're giving you a specific sleep tips, in order to improve your baby's sleep. And actually, the key, or can I say what guides the companies, is what value can we extract from visual data that the camera collects. So it's kind of obvious on sleep and, of course, on breathing for young babies. But also, this is the guidelines that guide us for the next products and features, how to give value in terms of wealth and wellness to our customers. And it's also really unique since also this product has 2 hats, basically. We can have the hat of a consumer electronic product as you use it. And it's also a research tool, which started to being used more and more recently. Researchers are doing the home sleep research. So it's pretty cool that, science and technology are working together, and we get to deliver a really interesting product.
That is really cool. And I think, folks who are listening to this who haven't had children yet might not realize how essential sleep is for your sanity as a parent, and how important sleep is for the sanity of your child. So
for everyone,
I definitely thought much more about sleep in the last year than I ever thought about before.
One of the key advantages of the product is, as parents, you get up at night for your children and you're drowsy and you don't remember exactly, did I get up like 2 times? It was at 3 a.m. Maybe it was 5. I don't remember. And Nanit just collects you the data and serves to you clearly, and in order to make useful summary of the night, and you can also make data-driven decisions if you want, and not by beliefs, because this whole field of babies' sleep is full with beliefs. Some say that this method works better, some say the other, and here you get the facts. You get the data. The baby slept well. The baby slept better. The baby didn't sleep that good this night. And we also see that, since parents are more focusing on the baby's sleep, also babies with Nanit sleeps better. They sleep longer, their sleep quality is better, because everyone is in this process and they're focusing. So it's pretty amazing, I must say.
That's really amazing. How do you know that babies that use Nanit sleep better?
So we have a large user base, and we often send surveys to our customers. And they actually respond to that. And we see in the statistics and in what they're telling that just babies with nanny can sleep better because you're more aware of that, and the tips are useful. So you're in a mindset of improving and how sleep is important. So I guess
Wow,
that's it.
that's very cool. So, can you break down what since this is supposed to be an ML podcast, although parenting has been coming up an awful lot lately with people we've been talking to. Can you kind of break down the pieces that are kind of ML problems or computer vision problems that you need to solve to make the app work?
Yeah, so we use all sorts of computer vision algorithm in order to get good understanding of the scene. I mean, in order to know, for example, when the baby is falling asleep on his own and whether a parent comes to visit or not. All those are actually computer vision problems that we need to solve. And we actually serve multiple models during the night in order to get the whole scene understanding. And on top of that, we take those outputs from the models and serve you the data much more clearly. So there's been a lot going on during the night.
And so do you run the models on the phone or do you run them in the cloud? How does that work?
Mostly in the cloud. We do have some algorithms that running on the camera as well, but mostly on the cloud.
And can you give me some sense of like what the scale of this is? Like how much data your models are handling, or like how many streams of video you get in a typical night?
Yeah, so let's take a short example. We have more than 100,000 users, and we have a full night, which basically means that if we serve, for example, every 10 minutes or so, we get into few tens of millions of calls for models per night. So it's a nice scale. I mean, we get to serve over tens of millions of requests per night to all our users.
And these are pretty sensitive models, and I've noticed that you've never gone down. I mean, at least in my experience, like it seems like you do a really good job with reliability, and I would think you'd have maybe a higher reliability bar than some other applications of folks who talk to.
Yeah, well, you're right. Since babies are actually the most important things to the parents, we try to be reliable as possible in terms of robustness of the models and accuracy of the models, and also in terms of runtime and to reduce downtime as much as possible. Because again, as everyone expects our algorithms to work all the time and give them the data, especially when it comes to babies. So we're putting a lot of effort on that as well.
And I guess the sleeping model is important, but the one that must be kind of anxiety producing. I mean, just talking about it, it's giving me anxiety. But the breathing motion monitoring, is that also an ML model that checks for that?
Well, we use multiple models there. So there are some models that are more of machine learning, deep learning based, and there are some computer vision classics models as well. There are all sorts of models.
And why do you use multiple models for a single application?
Well, we have many tasks that we need to solve in order to get this product to be reliable and robust enough, especially when we're talking about breathing motion.
So I guess when you look at like handling all millions of requests per night, I guess, like what are some things that you do to make sure that this is reliable and make sure that your compute spend is sane? Like how do you think about like model architecture and how do you deploy your models, and what frameworks and tools do you use?
So it's pretty interesting. At our team, we actually responsible for the whole flow end to end. I mean, from developing and defining the task, all the research, selecting the model architecture, even conducting a proof of concept. Many times we'll probably elaborate on that later because I think it's really important nowadays for practitioners in the industry. Also, the whole training process, of course, where you come in the picture with some great tools helping us find which models and experiments are better. Evaluating, which is actually pretty interesting because we try to conduct an evaluation metrics that also holds the product objectives inside as well, because we're not building models in vacuum. We're all tied up to a product and a value to give to our customers. So it's not always that straightforward. And until deploying to production, including building monitoring systems, which should be our eyes out there eventually, and runtime optimization, as you said, not to spend so much on compute. So it's pretty complicated flow, but over the last few projects, we actually formed a nice formula for it, which I posted on Medium blog post as a guidelines, which proven to be successful in the past few times, and it's actually in the trend, at least as I see it now. I mean, every time I read on Twitter, on LinkedIn, or whatever about people that are talking how to maintain and deploy and make good models in production, because there isn't any silver bullet out there. So, and there are companies that are always trying to solve the whole pipeline, some part of it. So it's pretty interesting. I mean, the focus, as I see it in the industry, is shifted from sometimes making the models into make them work well in the real world and be able to be flexible enough and adapt changes. So that's, I guess I can say that many times maintaining the model and make it good and reliable out there is sometimes much harder than actually developing it, which is kind of amazing if you think of it. I guess that wasn't exactly the focus like a few years ago, but kind of like get there.
Tell me some stories about, some stuff that you've run into, and tell me, like, if you could tell me, like, specifically, like, maybe pick a model and what it does, and kind of like what were the issues that you ran into in the process of getting it deployed and running.
Yeah, we can take object detectors as example. We use them, of course, in our product. And
in this case, an object detector would be like a baby detector or like a parent detector. Is that?
For example, fair? Yeah, it can be. Let's say, for example, a baby detector. And so when you take a baby detector and you actually want to start building it, you must be aware of, for example, the evaluation on how you're going to be performed. I mean, that's a common pitfall. I mean, people choosing the right evaluation metrics is pretty tricky. And I know that I can say for myself, I have to recover from some bad decisions, and it's actually how you look on the model. And
if you could break that down, I mean, so like what would be a bad evaluation metric from a baby detector? Because I can think like probably some people are listening to this and thinking like, okay, like accuracy sounds like a pretty good metric, but like what would be kind of a metric that might lead you astray with a baby detection model? So
okay, let's take just a toy example about it, and let's say we have a baby detector, and its accuracy is let's say it's pretty good, but we care more about eventually in the product we care more about the false positive than the false negative, for example. Okay, and how you look on the evaluation metrics can really affect that. So if I'll give a little bit more weight to the false positive, like we saw, for example, a decrease in accuracy on some metrics that actually average everything, and once, but eventually this is the right metric and we get a much higher performance. Or also the other way around. I mean, we have a model that has very high accuracy, but eventually, since the product was aimed to try to decrease false positives, the product metric was way lower. So it's really how you look at it, and that's the tricky part, I think.
So I guess what metric then could you move to, and then what would you do to improve that metric?
So once you define the metric, you can always try and see where are the weak cases and maybe how you can strengthen them, even if it's more data or even if it's a special kind of annotation of augmentations. So, but again, those things can be under the radar if you don't give them enough weight. I mean, that's a common failure case that actually happened in the past.
Wait, so can you explain one more time, like what happens there in this failure case?
Yeah. So let's say, for example, we took an accuracy overall measure for a baby detector, but we misdetect, the baby when it wasn't there, but we had the high recall and which compensate that. And eventually we got to very high accuracy. But for example, for other product purposes, the precision needed to be higher in order to give enough value to the product. And so it's actually another way of looking at it is looking over the precision as the biggest parameter for us. And so once we changed to look at that, we could clearly see the problem and fix that.
And how do you fix a problem like that?
So collecting the data, I assume, in a much dedicated way to your problem, maybe see whether you're actually collecting the right data and not just, maybe random sample the data at some point, but actually direct yourself to the places the model will look when it's in production. And so you want to try to imitate that and collect data from those parts in order to make your model trained on what it's actually going to see and not on what's easy to collect. That's one of probably the best solutions.
So collecting data of the cases that where you think your model is struggling and adding that as opposed to random sampling.
For example, or maybe collecting the right data to your problem. I mean, you can collect data in many ways, and collecting the data that suits your problem is the first thing. Actually, I think you need to do and put a lot of thought about it. It's actually my first bullet on the guidelines. Start by defining what's the right data for you. Don't just collect data and start working on a model because you're gonna waste time.
And do you have ways of explaining to a business person how to justify the cost of data collection in terms of some metric that they care about? Like, is that an important thing to you?
We try, Nanny, to keep a close connection between the product and the algorithm performances because, data collection is very expensive and our time and our resources are very expensive. So we try not to make perfect models that will have no effect on the product. So yeah, I guess this process is pretty easy for us because this is one of the first priorities when we start a project.
And are you also in parallel experimenting with different kinds of algorithms or doing hyperparameter searches? Like, is that important to you at all, or is it really just the data collection?
No. It's data collection is good, but we're doing all sorts of hyperparameter tuning and choosing models, and we have really organized methodology about what to do first. So
can you tell me your methodology?
Well, not in particular, but I guess a good thing to do is maybe start with trying to get the best model you can get and trying to get an upper bound of performance and, ignore speed, ignore runtime, for example, just to see what you're up about from the program. Because in many cases, the algorithms are working on public data sets and everyone, detectors work on MS COCO and classification, for example, on ImageNet. But not in all cases, it's a good proxy to your problem. Medical images have their own data sets, but some other parts, the data is not always, natural image style. So you got to try models and many hyperparameter tuning. It's most of the work from the training. I mean, it's not actual work, but it takes a lot of time. So.
And then once the model's deployed, do you stop there? I would imagine you'd have you'd have kind of new problems that would come up. Like, do you see like data drift as an issue for you, or like how do you think about production monitoring?
So we put a lot of effort in production monitoring. I think it's really important, and people sometimes underestimate that because once you deploy a model, I guess it's not ending. It's actually the beginning because it's much harder and you need to invest real good planning and making your monitoring systems to be reliable enough and give you enough confidence, because once you deploy the model, that's the whole thing you can see. And the performance on the test that you get before you deploy the model is just a single time. And after that, you'll get many timeframes with performances and you need your monitoring to be reliable enough to spot some shifts and maybe sudden drops and try to understand what happened. So I guess I can say that we never stop with the models. We always look on the monitoring and see where we can see any problems and what it's connected to. So
I think one of the issues is you don't really have ground truth in production. So how do you know if there's a problem?
It's true. It's pretty complicated. So we always consider prediction distributions and common stuff like that. We also use other routes as well. For example, user satisfactions and maybe tickets they open. And so we can spot some maybe problems there that we didn't caught up in our monitors. So we try to find the source whenever we can, and usually from other parts of the company as well.
Interesting. I always wonder like how people do. I mean, I've heard different variants, but will you actually file a ticket against the ML team if you find like a bad prediction? And then like, what do you do with a ticket like that?
Well, they don't file it specifically to the ML team, but yeah, people file tickets for bad predictions because everything is actually based on that. So you can get wrong statistics and bad results, and you're a parent, you want to get the data for your child. You paid for this product, and you want answers. It's actually quite a challenge. I mean, since we have so many users, and we need to keep our models in a very high performance level in order not to make so many tickets for us, and also make the experience for our users much better. So it's a challenge.
And one thing you talked about in your paper or your Medium post was kind of preparations before deploying a model to production. Can you talk about like how that works?
Yeah, we try to simulate as much as possible how everything will be in production. For example, we actually create a production-like environment, and we also get some of the users to use that. Of course, they are supportive and they are aware that there are going to be changes, and we try to monitor everything we can there in order to see that our model performed the way we expect, that we don't see any issues. And that's, of course, in parallel, we also do all those end-to-end tests of all of our algorithms together to see that the new model behaves as it should be and it doesn't raise any special problems from inserting a new block or maybe improving them. That's most of the work that's done there.
Got it. Could you tell me a little bit about how weights and biases fits into your workflow and how you use the weights and biases tool?
Yeah. So with weights and biases, we manage all of our experiments, which is great. We also use your visualization tools in order to compare between experiments, and since you have everything so shiny and dynamic, we can also try different parameters and see what could have been, and without running all the model over and over again, which saves us time. I'm a pretty huge fan of the reports that you can do because, as I said before, we are really tied up with the product team about the algorithms we do. So it actually makes us a way to show them what we do and visualize on real time how each parameter affects the results, and we talk about what should be better for the product and the algorithm team together. So yeah, we use it quite a lot. And
so you actually use reports to share results with the product team?
Yeah, we also use reports to summarize and share with product teams, show them some maybe model weaknesses, whether we want to deal with this now or maybe deal with this later, and for example, how changing parameters can help. It's better for mutual work and transparency, because sometimes you're trying to be a little bit suspicious from things you don't understand. And once we understand their job and they understand our job, I think the mutual job is much better. We've seen that once you talk about it and you explain, and they can understand your world and you can understand theirs, we can make decisions which are much more good for the company. So it's actually pretty useful for us.
Do you often go down paths where there's like a product feature you might want to make, but you're not sure if you're going to be able to make the machine learning algorithm accurate enough or powerful enough to actually make the feature possible? Do you ever get in situations like that?
All the time. This is one of the main challenges we have when working with this scale and working on such sensitive data. I mean, we got so many cool ideas and papers and works, and it's really hard to get them into production. This gap is sometimes pretty big. I can, just name one example that pops into my head. GANs, for example. GANs, for example, they're amazing example for that. They do marvelous things, but it's really hard to get them into production. I mean, they often tend not to converge, and it's worked well on this data set, but not on this data set, and this data set's worked not good enough. So it's a pretty big challenge how to be innovative and giving good and valuable features, but also reliable and accurate. Which is
what might you do with again? I'm trying to picture that. Like I don't want any deep fakes of my baby.
No, not deep fakes, but there are many other uses of GAN that we can use, maybe for enhanced images and make your nice fun features. That you can celebrate, like your baby with different background and stuff like that. So there's all sorts of stuff that GANs can be really useful. But again, there's a big gap between an experiment and a paper and actually getting into production.
I mean, I know that in the last couple of years, there's been a lot of advances, like almost like a tsunami of advances in computer vision. Have any of them been relevant to you? Like, do you take recent stuff and get them in production, or is that stuff like too kind of theoretical to really matter for the practical stuff you're doing?
We always try take state of the art and trying to adapt them to our domain. There are fields which is easier, maybe mainly object detection. We talked about it, so it's since tasks are pretty much solved, let's say, or pretty much comfortable to get them into production. So yeah, it's much easier. But there are other fields that we try. I honestly say we try all the time. It's sometimes really hard to bridge this gap, but it's definitely something that keeps us motivated and try to do it all the time. I mean, if you stay behind in this field, you probably won't exist that long. This is what I believe.
Sure, yeah. Is there any, I guess, any paper or like line of research that you can talk about as being especially relevant to the work you're doing?
I can talk about some nice researches we did lastly, and all of them are actually somehow related. I mean, they're all using the sleep metrics that we have, which have the algorithms at the back. So for example, during the pandemic, during COVID, actually Nanit helped to keep families together. For example, when the grandparents can see their grandchildren and Nanit allows that. And we also checked during COVID what are the effects on babies. And we actually trying to study the difference between children that their parents were essential and went to work as usual and parents that stayed at home. And we actually saw that at the first few weeks, like from the end of March, let's say for the first few weeks, we saw that the sleep of the babies actually got worse.
Wow.
But it was actually improved after a couple of months. We saw that those the sleep of the babies that their parents stayed at home actually got back to normal, which is pretty amazing. It actually means that babies are resilient to the change and they adapt back, which is kind of cool.
Can I ask you? So this is, I mean, this is like I think for a lot of parents, the most drama filled topic is kind of sleep training the baby, where you leave the baby and let them cry at various lengths and kind of teach them to go to sleep on their own instead of with you holding them. Do you have an opinion on that?
Well, since I'm not a sleep expert, I can only say from my experience, it's important to let the baby sleep on their own. I guess not at any cost, but
do you have any data on that? Is it? I guess you do sort of track when the baby falls asleep on their own.
Yeah, we do. I'm not sure if I have any relevant research done in this field, but again, this is the beauty of Nanit. I mean, you can actually test your assumptions, I would say, because if you believe in that, and then the objective data tells you that it's right, so that's good. And if not, so you might want to reconsider, but that's up to you. I mean, you got the data, you can decide.
Do you publish like aggregate statistics like that on different things that help babies sleep?
We do have researches that we publish. I'm not sure regarding those what helps and what doesn't specifically. We did publish research about screen time and how it affects babies and young children, and it's actually pretty amazing. We found out that, for example, touch screens have a bigger effect on the sleep of babies as opposed to, for example, television. I mean, television has less effect, which is pretty amazed me. I mean, we saw that touchscreen have causing fragmented sleep and less sleep time overall, which is pretty, I mean, it's pretty amazing. You can conduct the research and see it quickly because we have large user base and engage users that can allow us and answer questions. This is what makes us also a good research tool.
That really is amazing, yeah. And it seems like, I guess, from your app, I feel like your benchmarks of sleep are actually a little less sleep than I see in sort of like the parenting books that I read. Do you think because you're actually monitoring it instead of getting self-reported data, do you see systematic bias in the self-reported sleep data? Like it'll sort of tell me like, how my daughter's doing, like kind of compared to averages. And it's funny because the app is kind of telling me she's doing pretty good. But then when I compare it to like, books that I'm reading, it seems like she's sleeping a little less than average. So maybe you're just trying to be like, positive and helpful. But I also kind of wonder because, we try to write down every time she wakes up and like, when she goes to sleep and when she gets up. And I always kind of feel like our written notes imply a little more sleep than the data actually shows us that she got. And so I kind of wonder if previous studies relying on kind of parents' memories end up making us think that babies are sleeping more than they're actually sleeping.
So what I can say about it, so I guess that's sometimes true. Also, I guess getting data for babies for sleep, especially from babies, is pretty expensive. I mean, I'm not sure researchers can do, thousands of babies and then record their sleep, what Nanit actually can do. So maybe, there's some small portion. This is why you see some big variance between studies about sleep, I guess. So I guess that would be the reason.
I guess
this is my assumption.
Is there any other takeaways besides avoiding touch screens to help a baby sleep? Any conclusions you've come to with your large scale data collection?
So most of actually the significant tips that we see are actually incorporated in the app. So helping baby fall asleep on his own is, of course, a remarkable sign for that, because once he wakes up during the night, he can come back to bed. And so I guess what we see and what is we're trying to translate that and validate it, of course, and send it as tips if possible.
Cool. Well, I guess we always end with two questions, and I want to make sure we have a little time for that. So, the second to last question is, what is one underrated aspect of machine learning that you think people should pay more attention to than they do?
I would say building a good process for deploying the models. I mean, making something that works as a system and it's not occasionally work and not. Because sometimes people tend to, let's take the data, let's train it. Okay, it's very good on accuracy. Okay, we can deploy it, and then the performance are bad, and now the model is in the air, and it's much harder to fix it. So I'd say conducting this methodology, this pipeline of how to work better is something that people should pay more attention. And I think that's what we see, at least what I read on Twitter and LinkedIn and stuff like that. People are paying more and more attention to that. And I think that's important for the industry.
And are there tools that you use to help with that?
In building those pipelines, so we use whatever, for example, managing experiments and showing the report and see everything really helps us to get understanding on how it's exactly done. Try and simulate the production. Like, this is what works for us, but I know there are several companies and there are several products out there that can do many things, and this is why I wrote it as guidelines, because probably some of the tips there could be useful for many people, and some of them are not. So
totally. And then I guess maybe you've answered my last question, but I'll ask it anyway. So when you look at machine learning in general and making it work into production, what do you see as the biggest challenge from going from research to deployed model working for customers?
So as I said, I think this gap is sometimes really big, is the fact, well, maybe the ability to understand which paper is nice, but will it hold in production? It's a pretty big problem. You need to foresee it, and we've tried a lot of cool features that we saw in conferences and papers, but they didn't hold on our data, or maybe they weren't good enough, so we had to drop them.
Well, I really appreciate you being kind of public about your work and willing to do case studies and things like that. I think it really helps a lot of people learn best practices as they try to get models in production. So we'll put some links to some of the work that you've put out, but I would say please keep doing it if you're open to it. It's super helpful for our community.
Yeah, I totally agree. This is how we learned, and this is how we can share the knowledge. And I think as much as people will share the knowledge, it will be better, and everyone could have great productivity, which I think is important.
Totally. Thanks, Nimrod. Really appreciate it.
Thank you so much.
Thanks for listening to another episode of Gradient Descent. Doing these interviews are a lot of fun, and it's especially fun for me when I can actually hear from the people that are listening to these episodes. So if you wouldn't mind leaving a comment and telling me what you think or starting a conversation, that would make me inspired to do more of these episodes. And also, if you wouldn't mind liking and subscribing, I'd appreciate that a lot.